Good afternoon, Farmington. Actually, it's like 7 a.m., so I don't know why it's good afternoon, and I just burned my tongue on some coffee. We'll figure out if you can guess which day it is. Alright, rules of exponents. Here's the big thing. When we do quotients of powers, which is dividing, so I can divide monomials. So we did multiplying notes 3. This is now notes 4. Alright. You subtract exponents. And here's how you do this. This is hard to see. I'm pretty sure on your paper it's an 8 to the 6 over a cubed. And what you do is you subtract it. So it's like a to the 6 minus 3, which is equal to a cubed. Okay? The other way to think about it is this is a times a times a times a times a times a. 6 times, right? I'm dividing it by a times a times a. Alright, well if these cancel out, like you know they do, you're left with a cubed. Here's what I do. When I think of multiplying, when I'm multiplying powers, they're going to get really big, so I'm adding the powers. When I'm dividing powers, I think of them as getting smaller. When you're dividing things, they're getting smaller, so you subtract them. That's how I keep them straight, to know if I'm adding or subtracting. So let's try some of these. Notice both of these a's here in number 1 are just 1. Well, what's 1 minus 1? Right? They actually cancel out. You're just going to be left with 4b. It would have been a to the 0 power if you do 1. But we know a to the 0 is just 1, so we're not going to write it. Okay, that's all you have to do. Over here, I could put x here and y, right? So that I'd have 6x to the 1 minus 1, y to the 3 minus 1. Or if you're good at math, x to the 0, we don't write. That's just 6 still, and then y squared. Some of you might be thinking, this is really easy. Obviously, we don't have easy examples for all of you all the time. So we're going to keep moving forward. This is how we would want you to write this. Okay. First off, you deal with the coefficient out front. Don't forget about this. So 5 and 10, I know 5 goes into both of them. 5 goes into here 1 time, goes into 10 2 times. Okay. Then also I have x to the 2 minus 1 is going to be 1, and then I still have 1y left. And then I have 1/2. Alright, so I would say the best way to write this probably is going to be xy divided by 2. That's how Miss Johnson wrote it. I think that's pretty simple to look at as well. 4 and 14, I divide 14 by 2, I get 7. Divide 4 by 2, I get 2. So I have 2 over 7. If I have a here, a, you notice you subtract the powers, correct? So I have 4 and 3. Well, if you remember, a times a times a over a times a times a times a. If you cancel these out, you're left with the a on the bottom, or there was more a's on the bottom. However you think of this, 4 is bigger than 3, so just make sure your one left over is on the bottom. Where when we go to b's, we have 5 and 2, so 5 minus 2 is 3. I don't know how confused. If you're super confused right now, just stop the notes video, come and ask. Alright, and I'll try and explain it better than the notes video, because this is the easy side. Properties of simplified monomials. Okay, first one, each base appears exactly once. So for all those, we only wrote x or y 1 time in our final answer, or b and a 1 time. Okay, make sure your bases are only appearing 1 time. There are no powers of powers. That's our parentheses deal. Alright, if you have a 2 out here and a 3 in here, where that's not allowed, you got to simplify that, so we can't have any of that. And then the next thing would be, all fractions are in simplest form. And that's what we were doing. I think we had 5 over 10, and we simplified that to 1/2. Alright? Things like that, you got to look for those. Okay, that'll be a possible point off on your quizzes if you can't figure out how to simplify. And obviously, usually these are all written out front, and so those are our coefficients because they're written out front. If I go back, you can see they started out here. They started out front. So usually that's how you'll see them too. So don't worry about it. They're just, usually there's two numbers out front. So here, for example, flip it over. 5 and 15, they're out front. I see 5 again, so I'm going to go 1 and 3. Okay, it's hard for me to read. That's an x cubed and an x squared. So I'm going to have x to the 3 minus 2 and y to the 4 minus 1. Okay, and I'm going to have 1/3 in front. So for me, I'm going to write 3 minus 2 for x is just 1, so I'm not going to write to the power of 1. Y would be 4 minus 3, so y cubed still. 4 minus 3. 4 minus 1 is 3. And then I got to divide everything by 3. That's what our fraction means out front. I think that's the best way to write it. Make sure you're not confused by this is like times a third or divide by 3. You're dividing everything by 3. There's still 3 on the bottom. I didn't do a very good job writing it. Maybe I should have went like this. I don't know. Moving on. Awesome. I like the way this looks. 2 divided by 2. Or 2 minus 2 is 0. Or you should see that these x's just cancel themselves out. 27 divided, actually 27 goes into both of them. So this is just going to be 1/2. That's an easy one. This is really confusing the way I have this written. I'm moving back to this. I would write it minimum, wow, we'll go October colors. It is October. I would go like this. 3 minus 2, y, 4 minus 1. Okay, that would be a little bit less confusing so you know what's going on. Alright, then this last one. Ooh, last one. We're not even close to done. X times x cubed. So remember, these are multiplying into the same base. So that first x is actually 1. So 1 plus 3 is actually going to be 4 over x to the 4th. So you had to remember multiplying, you add those powers first, and then you should be able to see x to the 4 minus 4 is going to be x to 0. And anything to the 0 power is 1. So I wrote all that out for you so your brain should see how my brain works. When I looked at that, I got 1 right away, but we are here for you. We'll help you out. So now we got this power of a power thing. So what we want to do is simplify the inside first so that we're not multiplying by a big mess. But how I would rewrite this is I would write 2 to the 4th power. Then I would take b, p, and do it's raised to the 2nd power. Then you have to multiply. When it was the power was on the outside, you multiplied, and then over 3 to the 4th. Now, if you don't have a calculator, make sure you're getting one. 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, p to the 8th, and then if you put 3 to the 4th power in your calculator, you're going to get 81. And that is all the way simplified. So you're doing a little division, you're doing a little multiplying, all right? All this stuff is going to be fair game, especially on your quiz. So let's try this one. This one I can simplify first. I got this x to the 1 here, and I got an x to the 5 right on top. So I'm going to rewrite that as 5x. Well, 5 minus 1 is going to be 4. So you can see I simplified that a little bit. So now I have an x base, a y base, and a couple coefficients out front. That's fine. Then I would rewrite it over here. I'd write 5 to the 2nd power, x to the 4 times 2, y to the 1 times 2. Did I pull that 1 out of nowhere? No, this is the 1st power. They just don't write it. Then you should see 5 squared. Most of us know that is 25. If not, get that calculator out. 4 times 2 is 8. Y squared. And 6 squared is 36. I still only have everything written once. So that's a pretty good problem. Alright, so there's a bunch on the inside I want to simplify first here. this A, so I'm just going to write A once, I'm going to write B once. My 2's on the bottom. So what I have is I have 5 minus 1. So to get this one to cancel out, 5 minus 1 is 4. And then I got 3 B's. Well, I have 8. So 8 minus 3 is 5. So I can get rid of everything. Oh, I'm just left with the 2 on the bottom. Well, I'll just leave that. Okay. And then it's still raised to the third power. So now I got some multiplying to do. It'd be A to the 4th times 3, B to the 5th times 3, all over 2 cubed. So to me, that looks like A to the 12th, B to the 15th, times 8. Okay. Now, remember, what I did on both of these is I simplified the inside first. So I would do the inside first, because otherwise you're going to be doing subtraction where it's A to the 15th on top divided by A to the 3rd. Alright? I think it's easier to see 5 minus 1 instead of 15 minus 3 to get A to the 12th power. But do the inside first. It's going to make the multiplication and stuff easier. Okay. Last but not least, the nice little word problem. On your sheet, this is an R here. I knew that was going to be screwed up. We didn't fix the picture. Okay. So, write the ratio. So we got to know that we're writing a ratio. So I always kind of screw those up. So I got, write the ratio of the area of the circle. So area of circle over to area of square. Now, area of a circle, for those of you that don't remember, is pi. And then it's radius squared. Well, we actually have an r squared for you in your picture. Now, area of a square, we told you was length times width earlier. Alright. Well, what this means is when this radius is to the center of the square, it also can be drawn this way. So r. What that means is r plus r, this whole length here, is 2r, or the diameter. Well, we know that a square, if that's 2r, this is 2r. So really, for our area of a square, we have 2r times 2r. And we're really good at adding powers now and knowing that it's adding powers. So we would equal 4r squared. 2 times 2 is 4. R, 1 plus 1 is 2. So area of a circle is equal to pi r squared. And this area of a square is 4r squared. We have done enough math today that 2 minus 2 goes to 0, or r is just 1. They cancel out. So this ratio is pi over 4. So that's a cool little problem. Me being a geometry teacher first, I love problems like that. Okay, let's have a happy Friday. And if you're watching it on a Monday, too bad, too sad. Let's get some work done. Have a great day, everybody.